All right, so the way that pretty much I was already talking about how you need a minimum amount of information in order to create an accurate an equation of a quadratic. So either you need the vertex and a random point to create the equation of a quadratic. You need the x-intercepts and a point to create the accurate equation of a quadratic, or you need, minimally speaking, you need 3 points. With 3 points, you can create the equation of a quadratic. With x-intercepts and 1 point, you can create the equation of a quadratic, or with a vertex and a point, you can do it. These examples right here are creating the equation of a quadratic using a vertex and a point. Okay, so with that being said, let's go ahead and just work number, what do you want, 4, 6, well, let's just do 3 through 7. You guys just finished it supposedly. So number 3 through 7. So on number 3, here's your vertex, here's your point. Your vertex is at -2, 6, and your point is at -1, 3. So vertex is at -2, 6, and the point is at -1, 3. All right, so from there, you're going to use, because you have a vertex and a point, you're going to use vertex form. Y equals a times x minus h squared plus k. And you're literally going to solve for a by plugging in a y value, an x value, an h value, and a k value. And you get all those values from right here. Your h and your k are linked with the vertex. Here's your h, here's your k. Your x and your y's are obviously from the point, and we call those x and y. I mean, it's just, that's your x and that's your y value. And you're just going to plug straight into that vertex form. So starting off with the y value, I've got 3 equals a times x value is -1 minus k. So if my vertex went, well, you can think about it two ways. Minus h. H is -2. So minus a -2 would be a +2. Or you could just remember that inside that parentheses, everything shifts opposite. So if you went left 2, it better be +2. Okay? And then you also went up 6. So here's my equation, and that's not the equation of a quadratic. That's just an equation that I'm going to use to solve for a. That's my whole objective initially. Solve for a. So I have 3 equals -1 plus 2 is 1. Squared is still 1. So I have 1 times a. All of this right here, that's all 1. 1 times a. So I'm going to write it like this. 1a plus 6. I'm going to subtract 6 because my whole objective is to solve for a. So -3 equals a. So there's a. Once I have a, the reason I did that was I want to rewrite this equation now with my a value, my h value, and my k value. Remember, h and k, those are from this vertex. So here's my entire equation. Y equals, here's a, times x. H was to the left 2, and k was up 6. And that's the entire answer. You guys have questions on that? Let's do it 2 more times. 2 more times. And by duplicating it over and over and over, you're going to see it's just a pattern. It's the same thing over and over and over. So this time, my vertex, so going on number 5, says my vertex is 3, 2. My point, my random point, is 13, 8. So here's h, there's k, here's x, here's y. Vertex form. Y equals a times x minus h squared plus k. We're given a vertex and a point. I'm going to use vertex form. All right. Y is 8 equals a times x is 13. H, well, I moved right 3, so I'm going to do -3. I don't know why I just switched colors. Oh, well. K is up 2. All right, there's your equation. Again, your objective is to solve for a. This is not necessarily the equation of a quadratic. You don't even have, you're not dealing with x squared. You're just solving for a now. And that should be pretty easy. 13 minus 3 is 10. 10 squared is 100. So you have 8 equals 100 times a plus 2. Subtract 2. 6 equals 100 a. Divide by 100. It's 3 over 50 equals a. So it looks nasty, but it's still not difficult. So I have a. So I'm going to use a and rewrite this equation with that a and with the h and the k that are from the vertex. So here is my final answer. I'll just write it over here in green. I have y equals a times x. I went right 3, so minus 3 squared, and I went up 2, plus 2. In the back of your books, if you want to check that, 3 over 50 might be written as a decimal. Yes, yeah, decimal fraction, guys, it's all the same thing. Decimal fractions, percents, it's all the same thing. Different ways of writing it, but all the same thing. Do you have a question? Okay, well, figure out how to put it into words and then ask it in a second. I'm going to do it one more time, okay? Your question might get answered when I do number 7. All right, one more time. So number 7 says that my vertex, and notice it's the same thing over and over, vertex, -6, comma, -12. The random point is at 0, comma, -24. So that point is just somewhere on this curve. Vertex and the point, that means I'm going to use vertex form, y equals a times x minus h squared plus k. Again, this is h, that's k, this is x, that's y. Okay, so y is -24 equals a. We don't know a, that's what we're going to solve for. X is 0. H, I went left 6, so I'm going to put plus 6 squared. K, I went down 12, so I'm going to put minus 12. I'm going to use that to solve for a. So 0 plus 6 squared is going to be 36a. So I have -24 equals 36a minus 12. Add 12, -12 equals 36a. Divide by 36. So I have -12 divided by 36, or -1 over 3 equals a. So there's my a value. That's not the answer, that's just how I can write the rest of my equation. So my job, again, rewrite this equation right here using that a value and using this vertex. So here it is. Y equals a, which is -1 over 3. X, I shifted on my vertex left 6, so I'm going to put plus 6 squared, and I shifted down 12. And there's my vertex equation, or my equation in vertex form. Did you figure it out? Awesome. Any other questions on this stuff, guys?
It's easy now because you like the H and the K.
Yeah.
Like, I don't know. Before I was just memorizing it. Now like that.
Yeah, guys, it is really easy. Like I said, if you don't understand it, you're probably overthinking it. Literally, you're just filling in the missing variables.
Yeah, I do have a question on that. I do know which one is the vertex.
So the question was, on the graph, how do you know which one's which? How do you know which one's the vertex and which one's the random point? The vertex, as we learned it earlier, is always the minimum or it's the maximum. It's the one on the very top or it's the one on the very bottom. So in every case, vertex is here, vertex is there. If I have this random curve, that's where you're going to find the vertex. If I have this one, that's where you're going to find the vertex. Okay? -b over 2a, right? Okie doke.